Hello, grade 12 students. I wish you are safe and I wish to see you soon at school. In this lecture, I'm going to explain an objective about the intermediate value theorem. Okay? First of all, if the function satisfies the two conditions, if it's continuous on an interval, and if f of a times f of b is less than 0 is negative, then the equation f of x equals to 0 has at least one root. What's the meaning of a root? Means the curve cuts the x-axis at least by 1 point. This is a theorem. So the theorem, it has a converse. So how can you prove, for example, that f of x equals to 0 has at least one root? You have to satisfy the two conditions. You have to prove that this function is continuous, and you have to do f of a times f of b. It should be negative, okay? So this is a theorem that you can go backward and forward. Let us take an example. We have f of x equal x squared plus 4x minus 15 defined over 0 plus infinity, and they are asking you to show that it admits a unique root. So we are going to go backward in this case. So we're going to do the converse of the theorem. So you have to prove two conditions. You have to prove that f of x is continuous, and you have to do f of 2 times f of 3 negative, okay? So first of all, let us prove that it's continuous. How can I prove this? We need first of all to do the derivative. So what's the derivative of f of x? F prime of x equals 2x plus 4, okay? 2x plus 4 over 0 plus infinity, this is a positive derivative. If f prime of x is positive, then what can we say? We say that f of x is strictly increasing, okay? So the first condition is satisfied. So f of x is continuous and strictly increasing over its domain, okay? So this is the first condition, okay, which is admits a unique root alpha. Now we're going to prove that alpha is between 2 and 3. So this is the second condition. How do you prove this? You do f of 2. F of 2 after calculation is minus 3, and you have to calculate f of 3. F of 3 after calculation is 6. If you multiply f of 2 and f of 3, f of 2 times f of 3 is definitely a negative number. So you satisfied both conditions, so we can say that f of x admits a unique root alpha between 2 and 3. Now how can I find the solution f of x equals k? K, it's any number between a and b, okay? How can we prove that f of x equals to k admits at least a solution? If we just prove that f is continuous and k belongs to this function. We're going to take and we have f of x equal x to the power 5 plus 3x minus 1. We need to prove that f of x equals to 1 admits a unique root. What we are going to do is, first we're going to find the derivative. The derivative is f prime of x, the same concept, okay? F prime of x equals 5x to the power 4, 5x to the power 4 plus 3, okay? 5x to the power 4, it's positive for every x belongs to the domain because this is an even power. So the first condition, that f of x is continuous and increasing, is satisfied. Now we're going to do f of 0.63, which is 0.98, sorry for the handwriting, 0.98. 0.98 is less than 1, okay? And we're going to do f of 0.64. F of 0.64 is 1.027, which is greater than 1. So one of them should be less than 1 and the other one should be greater than 1. So we can say that f of x equals to 1 admits a unique root alpha between 0.63 and 0.64. So if you have f of x equals to 0, one of them should be less than 0, the other should be greater than 0. If f of x equals to 1, one of them should be less than 1 and the other one should be greater than 1 to have a unique root alpha and to prove it, okay?